also run a YouTube channel about AI and algorithms and how we interact with them every day.
Awesome, thank you. Yuting, if you would like to go next.
Sure. So hi everyone, I am Yuting Kuo. I hope you all are enjoying the event and I'm very excited to join all of you today. I currently work on environment-aware AI and AI platform scaling at Microsoft. I have had the fortune to work on a number of AI technologies and applications in the last few years, including founding Microsoft's Azure Cognitive Services and developing a few AI applications, such as mobile AI keyboard app called Microsoft SwiftKey on Android and iOS, as well as an iOS AI camera app called Microsoft Pix. And in these applications, we use AI technologies to predict what users are going to type next, and then also pick the best photo shot among a burst of photo frames by looking at things like if your eyes are open or if you are smiling. So that's pretty much what I've been doing in the last few years.
Okay, with that, I think we'll move into our first topic. So in your bios, you each emphasize your work to connect people, whether that be global communities, companies, and their various fields of studies. At IvyHacks, our goal is to connect and reach as many people as possible too. How do you foresee AI and machine learning growing further into an integral part of global connectivity? And how do you vision its impact in terms of social good? And either of you can start.
Jordan, you want to start first?
You can go if you're ready.
I'm sorry, you want me to go?
Oh, I just said you can go if you're ready.
Okay, all right. So I think AI certainly has a huge potential for social good impact, and then also really connect all of us together on this planet. We're seeing more and more examples of using AI in solving problems that our society is facing. Just giving a few examples, things around global climate issues or agricultural productivities, endangered animal preservation, drug discovery, prevention, diagnosis, and treatment of diseases for the things that's going on right now, the COVID-19. We see a lot of these activities. And then also really reducing health inequality and improve access to care for underserved populations. We're also seeing quite a bit of examples on these. And then of course, accessibilities for people who have like hearing and vision challenges. I actually had the fortune to also work on an application called Seeing AI, where we actually apply computer vision technologies to help people who are visually impaired or blind that can simply use a phone camera and can actually learn what's surrounding them. And then finally, of course, we've seen examples such as really people using AI for cultural and heritage preservation, such as really saving the languages we speak, as well as some of the artifacts that we actually treat as a treasure that really kind of save them digitally. So I can keep going, but I hope this gives you guys a peek of what's actually possible and enabled by AI in the context of social good.
Yeah, I totally agree with all of that. I actually think that the applications for language are probably some of the more interesting ones that I've seen recently, both in terms of better understanding other cultures, but also in terms of sharing messages to people who may not, speak the language that something was originally produced in, and being able to create content that either conveys a similar message or conveys it in a way that people from other cultures can relate to a little bit better. And so we're seeing this in things like corporate workforce training, which has been interesting, where you might have someone create a set of seminars to teach you how to do a certain job, and then that can be essentially deep faked into a bunch of different languages with a bunch of different other people. So I think that that's definitely a really interesting area in terms of connecting cultures that otherwise might not be connected normally. And then would definitely agree, as someone who works in the healthcare space, the potential for AI systems in healthcare is really, really interesting to me. And I think it can definitely do a lot of good in terms of, you know, identifying conditions that people might not realize they already have now, doing kind of long-term projections of people's health and being able to possibly mitigate conditions that people don't have now and might go on to develop later. Anything in that sphere, I think, has the potential to do a lot to improve care across the board, but especially to improve care for communities that have been historically underserved.
Thank you guys so much for your insights. Our next topic is, what do you believe is the greatest achievement in the field of artificial intelligence / machine learning, and in the past 10 years or so, and what do you believe are the most important steps for the field to take as it advances into the future?
You want to go first, Jordan, this time?
Sure. I think the greatest achievement question is always a bit of a hard one. The thing that usually gets pointed to is any sort of state-of-the-art result, especially when it comes to computer vision. And while I think that those tasks are definitely interesting, we've made a lot of progress in developing both very large, but also more recently kind of smaller models that capture the same, or at least can achieve similar accuracy results to those bigger models in different ways. I would almost say that the bigger achievement is like the more recent stuff, and this is something that, you know, we're starting now and the field is only beginning, but especially as it comes to clinical care, work in explainable and interpretable models is really interesting to me right now, because I think that as these systems get further integrated into daily life, people need to be able to trust them. And having ways that people can easily interpret the algorithms that they're interacting with, I think will be a bit of a game changer in terms of how they get used, especially in clinical care, because in clinical care, on some level, you need to understand, you know, how diagnostic decisions get made, how treatment decisions get made. And if you can't explain how that process happened, then it can, you know, create issues in terms of integrating these systems into the clinic itself. So I think that that's probably the thing that I'm looking forward to the most right now. And then of course you can get into ethics and fairness. And that's definitely something where I see a lot of great work going on now, but it's probably the biggest thing that I think we should be focusing on in terms of next steps over the next several years.
I actually totally agree with what Jordan just outlined. I think these are actually very important. And I think in general that there were many significant advances in AI and machine learning in the last decades. And I'm going to be a little bit biased on my pick, given I primarily work on computer vision and deep learning for the last few years. Even though if you look at deep learning algorithms such as CNN, they aren't actually really that new. They actually were invented way back in the 80s and 90s. But however, I think really with the advancement of the new deep learning training due to the availability of big data as well as big compute, you think about the GPUs and TPUs, being really one of the greatest achievements in the field in the last decade. Today is really all these new deep learning training methods that's enabled by these big data and big compute. And if you think of such an investment really actually provided a path for us to take on problems that we were not able to solve or actually solve very well in the past. I'll just take a couple examples. If you look at speech recognition, deep learning really actually enabled us to reduce error rate from probably in around low 20s about a decade ago to below 5% today. And that's literally comparable to humans' performance. And then if you look at computer vision, deep learning also made image recognition problems solvable. Again, even about just a decade ago, this was not just a solvable problem. Things like image classification or object detection. And if you think of the image recognition, that we now also even achieve human parity in the ImageNet benchmark. And in NLP, I think Jordan was kind of mentioned that as well, that if you look at some of the recent development in super large models, such as Google's BERT or Microsoft's Turing NLG or OpenAI's GPT-3, they are all great examples of the amazing advancement because of deep learning on that. And I think going forward that I think that the most important thing is probably more about how we actually take this further in a way that, you know, a lot of work we do, particularly in the context of deep learning, is around pre-trained models. But how do I actually make these pre-trained models really work in many scenarios and applications in the context of the actual applications, right? And how do we actually make these AI capabilities being able to evolve and learn over time, and rather than waiting, let's say every 6 months or 12 months, we're able to retrain the large model again, and then we improve the capability a little bit more, right? This is called so-called SOTA. I think SOTA is great, but in the end, it's really about how you actually take these SOTA models, but they really apply in the deployment and really understand the environment, right? And then really being able to actually evolve over there, right? So I think this is actually the very important next step for AI to go.
Yeah, and also really quickly say that this isn't necessarily a step for the field of AI/ML, but I think that advancements in compute are going to be really interesting over the next like 10 years or so, in terms of parallel computing, in terms of maybe not quantum in the next like 5 years, but maybe in the next like 10, being able to deploy systems and train systems using quantum computing, things like neuromorphic chips are super interesting. So I think it'll be interesting to see how models continue to scale as compute continues to scale.
No, I think that's a great point. I think the other thing I would add is more on, we also need to actually really think about, you know, everything together, meaning from, you know, hardware, including, you know, computer chips, to software system, of course, to data and model, and then to software system, into the environment all together when we actually design an AI application, right? So I kind of call it co-design. Then we don't want to solve this on a sort of disjoint pieces, which we sort of, you know, more or less are doing that today, right? And I think we're going to see more and more of these all coming together. And so AI is not just about models. I think we heard about this all the time. Everybody talks about deep learning. Everybody wants to study deep learning, but in the end, it's all these things out together. And of course, I'm only still talking about the computers, but then you think about how the AI is interacting with human beings, right? And then with the environment. I think these are also not a lot of areas. I think Jordan's areas around this area is really only a human, you know, computer, you know, interface in the interconnecting. I think these are all the important areas that we need to think about.
Awesome. I have a few questions from the audience that I'll ask. So one directly following up the last question, what is the best AI which is created till now, according to you? Might be a bit hard, but.
Yeah, that's a really hard question because there's like a lot of different ways you can define the best, like in terms of use case, in terms of how well it actually performs. I guess things that come to mind, like when I think of like big like soda problems, I think of like stuff like GPT-3. I don't know if I'd call it the best model. I'd call it a very big model. So there's kind of a bit of a distinction there. In terms of the best model that like I found the most interesting, yeah, that's definitely a hard question. There's probably work in, so one of the things that I work on is target optimization for non-invasive brain stimulation. So there's a lot of interesting stuff going on there in terms of like Bayesian optimization of like treatment targets and stuff like that. And I'd probably point over there for some stuff that I find currently very interesting. But yeah, there's like a lot of different ways you can define best. So I think my answer would be it kind of depends on what you want to focus on.
So I'm probably going to go for a bit of and I think on one way I do see lots of great, and I think as Jordan was saying, that lots of great advancement on many of the AI related technologies. I'll probably actually pick a bit more from the application perspective, and I'm going to pick something that many of you might actually think is super small, but I actually personally think it's actually big in a certain way, which is that I mentioned about an application called Seeing AI earlier that where we use computer vision technology to actually help people who are blind or visually impaired, really actually having a way to really actually, sort of see the surrounding environment. And when we actually first released the app, we actually received a number of very, very touching feedback from users that who are blind and who literally were like basically saying like they were crying because it's a huge step from 0 to 1, meaning they weren't able to really see their environment. I mean, they can sense, they can feel, right? But they now all of a sudden there's a point out their camera and then look at the surrounding. The surrounding, and then the app will tell them that, oh, I see, two persons playing frisbee, or I see a TV in front of you, and then, or being in a restaurant, actually point the camera to the menu, and then the app will read what the app actually can see on the menu to them. This was like just not possible to them at all, and actually that's the thing I felt the greatest about AI. So again, this, I can tell you 10 technological improvement or breakthroughs, but I think this is movie the type of applications that really actually I felt that's great, and that's a really the right thing for really our humankind. So
I played around with Seeing AI like 2 years ago and can confirm that it is very cool.
Okay, and they're also interested in knowing, what are your views with regards to the opinions expressed in The Bitter Lesson by Richard Sutton? If you are familiar with that.
Sorry, would you mind repeat the question again? I didn't quite get it quite well.
Yes, so what are your views with regards to the opinions expressed in The Bitter Lesson by Richard Sutton, which is a blog post in which Sutton argues that researchers should be wary of seeking to leverage human knowledge into their research, as it often runs counter to leveraging computation?
Actually,
I haven't read the blog post personally, so I can't speak to the specifics of it. Based on that summary of it, I don't know. I think that there's always kind of two sides to leveraging human knowledge and model development. And one side is the potential biases and the other side is the potential insights. And being careful to make sure that you pull as many good insights as you can while not biasing a system to the point where it no longer reflects the population that you're trying to use it on is important.
Yeah, I haven't seen the blog either, but I tend to agree with Jordan's comment. And I think on the other hand, I think that it's also, like I said, that it is also important that when we deploy these AI capabilities, and how do we actually really ensure that the capabilities that you can evolve and learn, of course, learn the right thing over time. I think it's also very important to make sure that we do that way. So.
Okay, and how do you see autonomous vehicle being deployed in a large scale? And while you're answering that, you could also answer, beyond the improvement in deep learning for the last 10 years by increases in computing power, what do you think are new developments that are increasing the performance of AI and potentially in the future?
I mean, to start with autonomous cars, I think infrastructure is really the thing that we're going to need to work on. Yeah, especially when it comes to city driving. One of, I think, the things that will advance autonomous cars into city driving is having infrastructure that can kind of understand where cars are at any given time and understand where they're going and how they're interacting, to give cars a better ability, so to speak, to anticipate things that might happen next. And the infrastructure part is hard because then it becomes a government thing and a funding thing, which, like, improvements in infrastructure in most regions come very slowly and don't necessarily advance with current tech. So I don't know how long that's going to take, but I think if we started having some infrastructure surrounding autonomous cars, then people would be more likely to get them. It would be easier to integrate them into city traffic, and yeah, the deployment process would probably speed up a little bit. The second question was about advancements in deep learning that don't have to do with compute.
it was beyond the improvements in deep learning, what do you think are new developments that are increasing the performance of AI?
I mean, I think, let's see. So like compute is one. With more processing power, you can train better models. I think that more types of models is another one. So we're not necessarily just looking at deep neural networks anymore. We're looking at other types of architectures. Human ML interaction is another one. So like semi-supervised systems in terms of kind of on-device machine learning. And more personalized systems would be another place where you see better results. I think those are the things that come to mind off the top of my head. More insights into how models work in the first place. Black box systems are still on some level black box systems, but we're starting to learn a little bit more about how to open the box.
Okay, so I think for the question around autonomous vehicle, on top of what Jordan just said, I think she has a number of great points here, and I will probably just add on top of that is a couple of things. One is probably things around regulations. That I see is a lot of pretty hard in terms of now when you have an accident, you have something bad happens, who is responsible, right? Is it the car manufacturer, right? It is the person who were in the car, right? And how do we think about this, right? And then I think the other big question, even though I think over time we will be able to resolve that, but it's more also you do have a transition period, right? And we don't know how long it's going to be. Meaning on the road, you're going to have cars without driver, but then you're going to have cars with actual human driver, and how the human driver interact with the machine drivers, right? And I think these are also interesting. And also important topics as well, right? And again, I agree with a lot of things Jordan said, and personally, I'm optimistic about technology side, right? But I am a bit more worried about how we're going to see the development of regulatories as well as these sort of kind of transition, while we're moving towards potentially maybe it's all human, it's all machine drivers in the future, but how do we actually think about this, right? So I think these are still the big topics in general. And of course, you always have, ethics, and as well as, how do you actually, now we actually let the machine decide the fate of certain actions, right? You probably all hear all these choices between now when you have choices, if something is going to happen, right? Do you want an algorithm to make decision for you, or do you rather still want to make the person who is making decision, right? And again, who is also accountable and responsible for the decision that was being made, right? So I think these are all very important topics, not just technologically, but it's also societal, regulatory, as well as moral aspects.
Go ahead.
Yeah, no, sorry. And then on the second one, I think, again, I think Jordan also made a number of very good points. And I think in general, I think there are a few things that's going on now, right? One is now we're at this humongous 75 billion parameters GPT-3 models like GPT-3. And how do we actually take these big generalization model and then really make it work for many of the scenarios with, customization, or if you think about model adaptation, right, such as fine tuning or knowledge distillation, right? And how do you take these models and make these models running very efficiently, economically in many scenarios where you might just have edge devices, or you might just have even IoT, like very sort of constrained computing environment. How do you make this happen, right? And I think the other thing is also around how do we also make all the learnings actually on top of that, right? And even if you're able to do that, and how we can make all these learnings on all these different implementations, and how we can actually all learn and aggregate the learning together back, right? And then we can improve the baseline model, right? And things around, you've also probably heard about federated learning and these type of things, that's also ongoing. And then of course, and how do we actually evolve the model once the model is being implemented or deployed within the application, and how do we actually continuously actually improve the model and in a way that and again, this is a new field that's going on, is we call it learning to learn, right? And people probably have heard about the term called meta learning, right? How do we actually now continue to actually improve that as we go along, because there's no way that we can just build a model and then we keep going. At least in the current constraint, that's in the current methodology that we're doing today, right? When we say deep learning, it's really more deep learned, right? We memorize a lot of things. So the model memorizes a lot of things, but then how can we continue to learn, right? And the things that I think Jordan also mentioned earlier around, and how do we do it in a semi-supervised, right, or even self-supervised, learning, right, on these things. So I think these are all very important.
So on the note between the intersection between AI and humans, there were some questions about whether you had any thoughts or information on biological AI, such as cellular automata, as well as do you think AI could ever take over humans in the future?
So for like neurosymbolic and biological systems, I think they're definitely interesting. Evolutionary systems in general are interesting because the way that like we learn as humans is somewhat different from the way that traditional deep learning models learn, and modeling model development off of how humans learn, I think is just like on almost a philosophical level, but of a fascinating thing to do. In terms of, sorry, what was the second half?
There was one about biological AI, and then the second half was about AI taking over humans in the future.
Oh, the singularity, right. Yeah, I am not currently super worried about that happening anytime soon. I think that in the current form of AI, we have models that, although the types of tasks that they're trained for are getting broader, they're still designed for somewhat specific tasks. And so we're still kind of in that narrow AI range. And I think, I don't know whether it's, evolutionary algorithms that might get us there, or whether it's having a lot more compute and building a lot bigger models that might get us there. But I think that I'm currently a lot more worried about fairness and bias issues in terms of the impact that that has on like society than I am about an AI taking over the world, if that makes sense.
Yeah, actually, I'm also not super worried about AGI, but then I think on the other hand, I think the definition of AGI, it is still evolving, right? I mean, you could think on one way, you can think about this is when computers behave like human, right? But this is so you can also say that this is actually when, regardless of how computers behave or how they solve the problem, but they can solve the problem that we can solve, or even better, right? But then again, they are quite different. And I still see, in general, AI is where I'm actually much more optimistic on this movie. I think with the right approaches that we could actually definitely make it more of a helping us, right? This is more of a intelligent assistant rather than artificial intelligence in a sense. And then I agree with Jordan earlier that I think we're actually doing very well on narrow AI, right? If you look at specific tasks, you think about like the examples I gave earlier, you think of speech recognition, you think of image classification, right? Think of like, a model that can recognize all breeds of dogs, right? Or birds or insects, flowers. Honestly, I think they're doing better, much better than human now. Maybe with the exception of certain experts, right? But certainly for most people that, think of how many breeds of dogs that you can actually recognize, right? And then I think certainly AI is already doing much better, right? And I think this is more where I do see, at least in the next 5 years, that a lot of applications we can actually leverage AI to do some of these somewhat repetitive, but mechanical, but still require really fast, computation and as well as a kind of certain deep, very, very narrow specific task knowledge, right? And I think that's where AI can help us a lot, on that. Yeah, and I think in terms of the biological connection, that I'm not an expert of these. I'm kind of more of a, working on this from a computer science perspective. But I do think that AI is not. That's what I say. I think many of you on the call are probably already computer science major. But for those of you who are not, don't worry. I think AI is not just about computer science, right? And the computer science might be necessary, but it's definitely not sufficient. I mean, there are many disciplines we got to think about AI, right? You think of biological sciences, you think of biology, you think of physics, you think of even chemistry, right? And psychology, or even economics and business, right? And these are all the things that we actually all have to work together. And I think this is where I call it multidiscipline approach. That it's very important. And you think of MIT, MIT's Schwarzman College of Computing is precisely, sort of kind of moving towards that direction. Is really thinking about cross industry, thinking about cross discipline when it comes to, ubiquitous computing when it comes to AI computing.
Okay.
Hi.
Yes, I was just going to introduce you. It looks like we're joined with our third panelist, Katya. If you would like to introduce yourself, who you are, what you do, and anything else you'd like to share, and then maybe answer the difficult question of what do you think the greatest advancement in AI has been in the past 10 years, and what do you foresee being the next most important steps?
Yeah, thanks a lot, Jenna, for jumping in and introducing me. I am very sorry, guys, that I was late for our panel discussion, but I'm happy to hear that everything runs smoothly even without me being there, because one person should not block the progress, and at the moment is the progress of our discussion. So I'm going to give you a quick intro about myself, and then I'll give you the answer to the question. So I am Katya, I'm Bulgarian, currently living in Portugal, where I have an AI startup. But before I tell you about this, I'll start with the beginning, which is I studied computer science, which is something that never excited me very much until I discovered NLP, so natural language processing, which is where I did, which is what I pursued when I did my master's. And then I got really excited because, oh God, we can do some amazing things with programming, which are different than let's code this web page for our clients and things like this. After that, I worked in machine translation for a couple of years, which was really exciting for me. But at some point I left because I saw how the business needs of the businesses I was working for were clashing with what machine learning, and in these cases machine translation, can deliver, even though we did have amazing results as computer scientists and computer linguists building production-ready machine translation models. They were never too good, neither for the translators nor for the end client, neither for the salespeople in our team. So I decided that I want to leave NLP and broaden my skills. So I just went into general data science, where I experimented with a lot of different types of data, not only textual data or human written language data. After that, I decided that I'm going to go into more social and environmental projects. So data science and AI and machine learning are amazing skills that you can have, regardless of whether you have them right now or not. But at the end of the day, I decided that I want to use them to do something good for either the people or the planet. And then I worked on very interesting projects like, let's detect what's the amount of online abuse that women members of the parliament receive in the UK. For example, when it turned out that women daring to be politicians received a lot of sexist abuse on the internet. This is the unfortunate fact that we discovered from the data. We worked with detecting oil spills in Nigeria so that we see how we can minimize the environmental damage that the oil spill could do. So the AI, or the data science in this case, did not have impact on the environment, but we helped the people who were cleaning the environment be more faster in their reaction time. And most recently, I've been working with satellite images, which at the end of the day is, again, one type of data. You would have an image that composes of 14 different images, so a matrix of 0, 1, 0, 1, 0, 1. Okay, not 0, 1s. One pixel value can be 0 to 255, but again, something simple when you look at it from a mathematical or data structural point of view, but then something super exciting, because as soon as you build something and model something on satellite images, you could see, we could see it with our human eyes as well, and we could recognize it, which sometimes does not apply to working with other different machine learning models. So this is the intro that I can give to you. And then Jenna, can you repeat again the question? Because I forgot what it was. I know that you also wrote it in the email, but.
Yeah, it's kind of difficult, but what do you think has been the greatest development in AI over the past 10 years, and what do you see as the most important steps for the future?
Yeah. Okay, so most important development in AI. Oh God, this is a very difficult question. It's like the Hitchhiker's Guide to the Galaxy and the the answer to the question to the answer of 42. What I can say is I can speak about my personal perspective, and I think that we have made a great leap in using machine learning models or AI in our daily lives. And for me, the best thing that we did was self-driving cars, because this is something that doesn't take so complicated algorithms, but it really makes a big difference in our lives. I don't know if you've ever been in a car that drives by itself. I have never. I did implement some self-driving cars algorithms, and I really love that we can trust cars or buses or trucks drive us to places. Even though here you would have MIT who is working on ethics, and they are trying to train an ethical AI algorithm that would need to do different choices, difficult choices when a car is on the road. For example, whether a car should hit a baby or a grandma. When you need to hit, you know for sure that you're going to hit one person, and you have to make a choice on which person this would be, which the AI needs to know the answer to before they take the action, and the human driver would not need to. But we usually freeze, and then there is an accident anyway. So this is my answer to the first part of the question. And the second part of the question?
Yes, what do you think are the most important steps for the future?
For the future, so as I've told you, I have been working in the field of social entrepreneurship for the last 5 years, which is creating businesses that have both a solid business model, so we know how to make money, and we have an impact model, which is the end goal of the business is to make something better. Currently, I'm working on AI to analyze satellite images so that we can mitigate wildfires, and we don't have terrible wildfire disasters like we have every year in California, for example, last year at the end of the year in Australia. So for me, the direction that we go in the future is incorporating AI in problems that would solve a social issue or an environmental issue. So we could have AI to help us plant our or farm better so that we can have bigger produce yields, or we can have AI to help us reduce terrorism in different parts of the world. We can have AI helping us be healthier, and we have a lot of developments in digital health and health for AI. And a lot of different things like this. But at the end of the day, it's not exactly the AI, the AI itself that would make this progress. It's the movement from businesses to social businesses and solving some big issues with the help of AI. When we can use AI to help, sometimes we should not throw AI at anything that we would love to. So that's the answer to my question. I'll mute myself, and then whenever I need to, I'll unmute myself again.
Awesome, thank you so much. Now this is a question for all the panelists. There are a lot of people asking about how to get started in the field of AI. And so if you could give any recommendations or pieces of advice or ideas of good projects for someone who's completely new to AI and machine learning.
I can take that because I did study natural language processing, but it's a tiny part of AI. And then the rest of AI, I'm self-taught. So what I did is I started with Andrew Ng's course on machine learning in Coursera. It's very accessible to all kinds of audiences. The math there does not go deep enough, so you could understand it even if you're earlier in your studies. And it's a really great overview of I think it was mainly classification algorithms, and you might have one clustering and one recommendation system algorithm, but I don't know, it would give you the basics of what machine learning is. There is a good course on AI on Udacity, if I am not mistaken, but I cannot remember the name of the course. So basically what I'm telling you here are MOOCs, right? What you could do after that is you can find some groups of people. It can be your peers, or it can be someone who you find on the internet, so that you start playing around with projects. There are also a lot of hackathons like we're having right now that can help you be paired with other people, and you can start thinking about, okay, we need to solve this problem. What is the solution to this problem? Which algorithm should we use? Should we use machine learning at all? Is this a AI algorithm? Is this an AI problem? Is this a machine learning problem, a data science problem, a computer science problem? So that you start training yourself in thinking and recognizing these type of patterns. But I would say start with Andrew and G's course on machine learning if you're completely new to the topic. Thank you.
Jordan, you want to go first?
Sure. Yeah, I also took Andrew's course when I was getting started. So I did my undergrad in biomedical engineering with a concentration in electrical and a minor in computer science. So I wouldn't really call myself trained as a computer science. I got into machine learning by doing a summer research project in it. I was able to spend a summer at Stanford, and they actually assigned me a machine learning project when I hadn't done any machine learning before. So I took, the Coursera course that pretty much everyone takes. Fast AI is another great place that I started looking into when I was starting to actually get into model development. Because they have a very practical, I think it's actually called like a practical course for deep learning or something like that. And so if you're mostly into the applied side of things, then I would definitely check them out, because they have a really solid intro that'll get you up to speed pretty fast. If you're interested in more of the research side of things, then I would see if there are UROPs or summer research programs that would let you do that kind of stuff. You can also get internships. I spent a summer at Novartis doing like clinical data analytics, and so that's kind of how I got into like data science. And I found that to be very helpful to both understand kind of how to do different types of data science tasks, and for Stanford, how to do different types of machine learning tasks, but also what that kind of job is like, which I think is important, because there are usually structures in different, especially in industry, different companies or different labs that kind of govern how you code, and can inform the types of problems that you're trying to solve, the types of skills that you're trying to develop. And then, yeah, definitely circling back to what Katya said, like whether or not you actually need machine learning in the first place, whether you should be, incorporating interdisciplinary people to get a wider scope of the problem and stuff like that. So I would start with, probably Coursera and then Fast AI, and then see if you can find kind of short-term opportunities that let you, dip a toe in the water in terms of whatever fields that you're interested in going into.
So I think both have great advice in detail here. So I'm kind of probably provide a bit of take one step back and provide a bit of more of a directionally thinking that I have. I think first of all, I do feel I might be a little bit biased, but I do think that math is your best friend, right? You think about, you want to get in AI, and even just in the current context of the mainstream techniques that we're using, deep learning or machine learning in general, that, study hard on calculus, statistics, and linear algebra. And if nothing else, I think these are you can find them are very handy as you kind of get into the field. And I think secondly, I mentioned that earlier, that, regardless of what you're studying today, you are going to find it's going to be helpful as well. So, but basically, if you're just doing computer science today, go beyond computer science. I think there are many, many other fields that I believe that will be also coming later on. So I think that these are really kind of what I am thinking. And then finally, I think probably the most important thing is more of AI is not just about building sort of SOTA models, right? State-of-the-art models. in my mind, I think the advance of AI and machine learning really needs to co-design with many things together. I think I also said that earlier. You think about hardware, computer chips, you think of software system, you think about environment where the inferencing happens, you think about the interface of the AI system with the objects or human that the system interacts with, right? We got to think about all these overall, and we need to really tightly couple with the real world applications. Don't hide in academic. Even you stay in academic, you still have to think about real world applications and really partner closely with domain experts. And what I mean by domain experts here is more like you think about those people who work in manufacturing, work in finance and healthcare, agriculture and many other industries. But at the end of the day, we're solving real problems. We're not solving AI problem in a way, right? I mean, AI is great, but it's really more like we don't do AI for the sake of being AI. I mean, for certain people, maybe, but that's a very small percentage of us. But I think most of us really should think about we're still solving real world problems, AI or not, right? And how can we actually use AI to solve that problem more efficiently, more effectively, and hopefully, kind of develop more benefits for humankind, right? So I think that would be what I would have to say. And actually, sorry, one more thing. In the end, is really that's also keep an open mind and then being always curious. I think this is probably the most important thing of all.
Oh, I would like to add something as well here. You guys could also try summer schools. I went to one. There is a good one here in Lisbon. It's called Lisbon Machine Learning Summer School. There is one that is good in Copenhagen, which name I cannot remember. I think Stanford also has a summer school. So you can go dive in for 5 days into very technical topics. But at the end of the day, I love what Yuting said, which is concentrate on the problem and see how AI can help solve this problem. Thank you.
Okay, and I think we're at our time here. So if any of the panelists want to give any last minute thoughts, feel free to jump in.
Yeah, I can say something as well. So guys, don't be afraid. If AI is hard, that's fine. If machine learning is hard, that's fine. Just go do something that really excites you, that makes you happy. As I told you, computer science was not the thing for me, but AI made everything different. You can try AI and then you can see, okay, this is not the thing that I'm really excited about. Don't settle. Don't settle until you're happy with your profession and with your knowledge about what you need to do your profession and to solve problems in a good way. And this is everything from me.
I don't have much to add, but I do want to appreciate all the time people have here, and I enjoyed the conversation, and hopefully that everyone would stay safe and healthy in this pandemic.
Yeah, I also don't have a ton to add for the panel, but I'll just say that things like hackathons in undergrad were the types of things that definitely helped me figure out what I was interested in and helped me build skills and helped me learn more about how you use machine learning, but also a ton of other skills in practice. So I hope you guys are enjoying your time at IvyHacks. And yeah, I hope you stay safe in this very weird world that we currently live in.
Okay, thank you so much to all our panelists, and thank you for everyone for attending. Hope you have a good rest of IvyHacks.
Okay, bye.
Thank you. Bye-bye. Stay safe.